Okay, I welcome us all to this class on pharmaceutical calculation BDT 1253. We continue from where we stopped in the topic enumeration and notation. I think we concluded percentage in our last class, right?
Yes.
Enumeration and what? Notations. We are still under what? Notation. We concluded percentage, right? In our last class. So today, I want us to go into, we are done with fractions, right? Percentage. So I want us to go into exponential notation. As I said in our class. You have a question? Okay, remind me, what's that again? Converting what? Percentage to decimal. Okay, as in, give me an example. Let me give me an example.
Give you an example.
Yes.
Like this one that we did, 2.526.
Convert what?
227.500.
227 point what?
500.
To what? Decimal what? Fraction. So what do you think we can do to this to move it to the decimal fraction? Divide by what?
1.
And we get what? 2.27%. So if you have 25%, and I want to convert it to what? Decimal. What are you going to do? Divide by what? 100 and get what? 0.25. Then you move it to what? Common fraction. You get what? It's simple, right? So, because enough we have more. Are you sure? I watch how you are doing your like this, as if you are not seeing it clearly. Now, so with this now, I think we have done justice to this. Now let's go to exponential notation. I said it's called what? Exponential notation, scientific notation, or standard what? Form. Are we together? Exponential notation, scientific notation, or what? Standard what? Form. They are talking about the same thing. What's going on? In this semester, it used to come on time. What happened? Oh, there's no problem. Somehow, please solve it so you don't affect it, please. Okay? You say something. I should clean what? Okay. And is it this one that should be doing this? No, I don't know what she's doing there. Still now. Those you know. I'm doing your work for you. Now, so we are talking about what? Exponential. We call it scientific notation. We call it what? Exponential notation. We also call it what? Standard what? Any of them is scientific, not scientific. Scientific. Any of them is okay. Exponential notation. A standard form. Any of them is okay. Any number in this form, a times 3 to the power b, is said to be in what? Standard what? Form. Any number in this form, A times 10 raised to the power what? B is said to be in what? Standard form, or scientific notation, or exponential notation. And it has two parts. It has the coefficient and the index. Okay? It has the coefficient part and the index. This is the what? This is the what? Coefficient. And this is the what? Index part. This is what we call index. More than one, it's called indices. That's where indices came from, okay? Indices. That's where, so when we are doing law of indices, you are talking about how to add, multiply, divide this. Am I communicating? Now, the index form has two parts. The power and the what? The base. So, any number in this form, A times 10 raised to the power, B is said to be in what? Standard form. Where A is the what? Coefficient. And 10 raised to the power B is the what? Index. And when you come down to the index, 10 is the base, right?
Yes.
While B is the what? Power. So if you know the laws of indices, that is your O-level mathematics. If you know the laws of indices, there's nothing you cannot do with what? Standard what? Form. That's the base. That is the what? The foundation. If you know your laws of indices well, at least there should be up to 7 laws of indices or more. If you know the laws of indices, then you can handle any question on this. So I would advise you to go back to your mathematics. Go and revise your laws of what? Indices. But as we are solving questions, maybe I'll just be chipping in where we need a particular law. I'll just mention it, then we'll continue. So you picking it like that. I will not come here and start teaching laws of indices. We'll not finish. So, but as we are moving, if any place we need any of them in your calculation, I'll just mention them, then we'll continue. I think that is the only thing I can do for those that still have valleys to fill. Now let's see. Now, as we have in as we had when we treated fractions, we also have operations in this. Okay, we have addition, we have subtraction, we have division, and we have multiplication of different numbers in what? Standard form. Now, but before I will go into the operation, I will talk about decimal movements and how to handle numbers from ordinary number to ordinary form to the what? Standard form. There, even number that is a whole number, so far it has more than 1-2 digits, how you can put it in what? Standard form. And even those that have what? Less than 1 in division sense, less than 1. You know, if you say less than 1 can be okay, yes, it's less than 1. It's less than 1, yes. But if you take it by addition and subtraction, less than 1 can be minus 1. Hope you know. True of us, it can be 0. But if you are taking it in division sense or multiplication sense, less than 1 is what? 0 points. Am I communicating? So that's where I'm talking about less than 1. So we have number like 0.00 whatever, you can put it in what? Standard form, and how we do it. So without you need to understand the concept of what? Decimal movements. Decimal movements. And the decimal movements is simply means the movement of decimal points along the digits of a number. Movement of decimal points along the digits of a number. The decimal movement can be in 2 places. If it moves twice, you call it two decimal movements. Some textbooks say shift. Any of them is okay. Whether movement or shift is what? The same thing. So it can move to the right, it can move to the what? Left. And as the decimal point is moving along that number, what we have in the power of the index part of it will be changing depending on how it moves. Am I communicating? So with this now, describe now. I want to write out maybe 2-3 numbers. Then I'll describe what I mean by decimal movement along the number. Look at this number now. And maybe a number that has maybe 4,879. For example, now we have 0.0078. This one is less than 1, right? And this is above 1, right? Now, are you okay? Let me get different numbers in different forms. So you understand what I want to do now. Let's take a look at this number. 29.87. Good. Here, decimal movement is in different. The decimal point is at different what positions on these 3 what numbers. Now let's take a look at the first number. You want to change these numbers to what? Numbers in what? Standard form. This is ordinary what? Form. Now, do you know the reason why we change numbers to ordinary form? So the number can easily be what? Handled. You come across a number whereby you press your calculator will become tired and change. Your calculator will convert it for you in standard form. True of us. Yes. But the digits are many that you cannot even write. In fact, even your notebook cannot contain all of them. So you have no choice than to do what? Put it in standard form so you can handle them. Am I communicating? Large, very large numbers in standard form are used. Numbers that are very large that you cannot handle. If you use them in their ordinary form, you put them in what? Standard form. Or numbers that are too small, too minute, 0.00000 up to 20. How we handle it? Asking what is the weight of electron, the mass of electron. You know how small it is. It can be up to how many? Who knows here? Hey, come here. Here up to 31, up to negative. Come here. In fact, you got to say that they looked at the weight of. They will tell you that the weight of electron is negligible, right? Have you heard of that statement before? That the weight of electron is what? Negligible. Because of how small the amount of electron is what? But that of proton is negligible? It's not. I'm not to connect. So if you go through your chemistry textbook, they put it in more standard form because it's too small that you cannot handle it. To the reason that they rendered it what? Negligible. That it can't even affect any calculation you are doing because it's small. That's why some rays like gamma rays, you have electron, they take it to be the same thing with the what? Electron, because only the charge know what. Let us not go there. But the point I'm trying to make is this: it helps you to put numbers in form that you can do what? Handle them. Now let's look at this. Are you aware that I have defined standard form now? Are you aware that I have defined standard form? Are you aware that I talked about the reason why we use standard form? Yes. So you don't wait for me and can say, all right, standard form is, and why we use standard form? No, I don't do that. So as you listen, you do what? So I come to you and ask you, why do we use that? Hey, I didn't teach us why we use standard form. You didn't say it too. So please, I want you to always be what? Attentive to class and put down as many information as you can do. Now let's look at this. We have 4879. Now, are you aware that this number Where do you think decimal point is in this number? Where? Where is the? Is that decimal point in this number? Where the decimal? Where some system where we have decimal point in this number? It's here. This is 0. So if you start moving now, this is where the decimal point will start moving from. Are we together? It will start moving. It moves to this place. Remember, decimal movement is movement of decimal point along the digits of a what? Number. Here it's moving to the what? If you want to change this number now to a number in standard form, what are you going to do? It can move to this place, right? It moves here. You have what? 1, 2, 3. Now, as it's moving in this direction, as it's moving in this left direction, what do you think will happen to the power? Will it be increasing or decreasing? Increasing. Remember, are you also aware that this number is set as saying 4879 times 3 to the power 0? Yeah. Are you also aware? Yes. Because law of indices, I told you that as we move, I'll be talking about law of what? Indices. Any number raised to power 0 is what? 1. Are you also aware that this thing are the same thing? Are you aware? Yes. Now, as this decimal point is moved from here, as it's entering here, what will be happening here? It will what? It will be increasing. So here now, if you start from here and move here and stops here, see what you will form. 487.9 times 3 to the power what? 1. Now, and that decimal movement to the left again, it enters here. This will increase. We have what? 48.79 times 3 to the power what? 2. As it moves here again, bam, you have what? 4.879 times 3 to the power what? 3. As it moves here and stops here, what will be formed? 0.4879 times 10 to the power 4. As it moves here, what will happen? 0.04879 times 10 to the power minus. It's 5, no, not 5. It's 5, not minus 5. Huh? It's the same movement. It's moving. It's moving. As it's moving, this one is increasing. Are you aware that this whole or these numbers have the same value? This number, are you aware? All these numbers we are seeing here, they have the same value as what? This number. But we have what is called the stable form. Am I communicating? We have what is called the what? The stable form. The stable form of this number is what? Even though, yes, for now, you can handle it here at this level, okay? You can handle it at this level. But if you are asked to put it, if you are asked not to put this number now, listen carefully. If you are asked to put this number in, listen carefully. Note this number. Of course, you have noting what we say here. If you are asked to put this number in standard form, if this comes as a question, and you are asked to put this number in standard form, look at the answer here. That's the stable what? The stable form of this in standard what? Form. Now, look at it. This aid here now, if you break it down, what you have is what? 8.0. This 0 now can be any, maybe up to 2 digits after the 0. But the decimal point must be before a what? The first what? Digits. Hello? The decimal point should be after this what? The first what? Digit. That is stable form. You can allow it. unless there's a specific information you are given. If there's no specific information you are given, the stable form you should leave the standard form is what? After the first digit, what comes the what? Decimal point. You don't say 48.79 times 10 to the power what? 2. It's not stable. This is not this form. You should leave it, even though it has the same what? Value, but you should leave it what? At what? 4.879 this 79 depend on what you are trying to calculate, but if possible, leave it as simply what? 4.9. Am I calculating? Just leave it at 4.9, unless maybe the value here is not what you can ignore. Okay, you can run off like that. Okay, yeah, but if not, leave it at 4.9. That's how it will get close to 4 to 9. You simply do what? Leave it at 4.9. In fact, that is even the best form. You can leave it 4.9. But the basic thing is that the decimal point should be after the first what? Digit. These ones, they have the same value, but it should be after the what? First what? Digit. That's the point. That's what I mean by what? The most stable what? Form. You should do what? Leave it. Now, having noted this, now we can carry out different decimal movements on this number and generate different forms of the same what? Number. But at the end, the most stable form should be what? 7.8 times 10 to the power, whatever it is. Are we together? Now we have moved around an integer, right? Now let's move around this number, this decimal. Let's see what it will give us. Can I clean this side? Yeah? Okay. Now let's look at 0.0878. 0.078. Are you also aware that this is the same thing as saying this is the same thing with 0.0078 times 10 to the power what? 0. Are you aware?
Yes.
Are you aware?
Yes.
Good. Now let's go. But are you also aware that adding 1 to this is obeying law of indices? Are you aware? Are you aware? Now let's go back here first. Now the decimal point is where? Here, right?
Yes.
Good. Now let's do the first decimal movement. We'll start here, right? Are we moving to the right or to the left? So if you move to the what? Right. What do you think will happen here? So you can keep this as a theorem or whatever rule, that as you move decimal movement to the left gives a positive what? Power. Adds a positive what? Power to the what? Index form. Index part. Are we together? Decimal movement to the left adds a decimal put a, it's important. A decimal movement to the right, left adds a positive what? Power to the what? Are we together? Now, why a decimal movement to the right gives what? Adds what? A negative power. Simple. With that in the back of your mind, you can convert numbers from ordinary form to what? Standard form without any issue. Now let's look at this one now. As we move from here, this one decimal movement, see what it will give us. Decimal movement to do what? Decimal point will come where? Here, right? What do we have? It's funny. It sounds funny, right? Tell us what you should have.
0.078 times 10.
0 what? What? Wait. I want to ask a question. Should it be 0.078? times 10 raised to the power 1 minus 1, or 0.078, or 0.078 times 10 raised to the power minus 1. Which one should it be? It should what? Is it true? Yes. Is it true? Yes. Okay, good. This thing has no significance. Hope you know. Yes. Are you aware? Good. So we have what? 0. What? Times 10 raised to the power what? Now it will move again. Bam! It becomes what? Times 10 raised to the power what? Because you are adding negative, right? It will move again from here to here. We have what? This is the most stable form. It can also move, right? To what? You can move to 78 times 10 raised to the power what? Minus what? 4. They have the same value, but leave it as here. 7.8 times 10 raised to the power what? Minus 3. If you like, you can also move it again. You have what? 7, 8 what? 7 what? 80 times 10 raised to the power what? Minus 5. They have the same value. Honestly, they have the same value. Ask.
This thing, give me this thing because every like.
What is it?
Like you cover that line, this thing. This one. Like SPhT phenomenon does not even come above 1. I thought.
Okay.
All of it. I thought no. Our parameter. Our parameter.
I understand.
So in my inner confusion, this thing in my mind at no 0.
I said no. What do I call it? I said if you cover, I'll cover the gap whatever. Check your notes. What do you call it? I said decimal movement.
Decimal movement.
What would be a 0 here?
Yes.
Can you check it? See, there's something I want to tell you this. Class 80 physics. When we're explaining something, don't write. Listen. And then before you do what? That's what it means. When explanation is going on, listen and do what? Before you write. Okay? But if you focus your attention on writing, before you raise your head, you see things you don't know where they came from on the board. And you become what? Confused. And I think that's what's happening to Chicken now. She was just writing. She raised her head and saw this move. She was where they come from. She took us back down to me. Do you know where we left that part? Do you know how long we left this thing? You're taking us. But what else about of in this is that any number left for 0 is what?
1.
And the standard from this base is what? It's always what? It's 10, right? Yes. True of us. Now, if the base in standard form is what? 10, and I ask you, and I say that you are aware that this number here times 10 raised to the power 0 is 1 is the same number. Una say yes, and which is true? Is it true of us? Now, since it's true now, we start moving. We start and the points. I asked the first question I asked. Where does the decimal point is in that number? You said that it's after what? 9. Then I now put it in this form and started moving the decimal point from here to the left. And I gave a rule here that as it moves a decimal movement to the left, adds what? It pushes forward. So that's the arrow. As it moves here now, here because the point is now here. 1 is added here. That's why it turns to what? 1. From here again, it moves to here. Bam. 1 again is added here. It turns to what? 2. From here again, it moves to this point. Bam. 1 is added here. That's why it became what? 3. And from here again, you can also move again. Continue. That's why the point is now before 4. 1 is added, it becomes what? 4. You cannot move again. That's why at the 0 is here, at the point decimal point shifted to this point. And 1 is added, it becomes 5. But I said that you should leave it at the what? You can give me a number and ask to change it to what? Standard form. Leave it at the what? The stable form. And the stable form here now is that the decimal point should appear before the first what? After the first what? Digit. That's why I circle this. Do you know what I circle this one? Are you sure? That's why I said that you should leave it as 4 point what? You cannot approximate depending on the numbers here. I'm calculating it. So this you can read this as 4.9. I'll mark it for you. Only you 4.9 times 8 for what? 3. I'm not calculating. Is it clear now? Now when we now move to the negative parts, you know I listed different numbers. This is a number that is less than what? 1. So we started working on this. Here again, I see that this thing here is certain as saying, which you have agreed, that this is the same number times 8 to the power what? 0. Are we together? Are we together? Now, actually, let me even take it simple truth. Actually, are you aware that this number, if you just write this number like this, and still write it like this, times 3 to the power 0, it's actually a standard form. Hope you know. Yeah. But the rule is that we should leave it to the what? The stable form. That's why we are moving the decimal points. Simple. Hope you also. That's why we are doing this by the virtue of writing the same number and multiplying by 3 to the power 0. It's already a standard form. We hope you know. But you should leave it at the what? Stable form. That's why we are moving the decimal point and adding the power until you get to this first what? Digit. You leave it at that. That's where you stop. 3 of us. That's what we've been doing. And that's the origin of this decimal movement. We want the decimal point to shift and get to the what? After the first what? Digit. You stop. That's when then that will determine that number of movements and the direction of the number of movements and the direction of the movement determines what will be at the what? Power. So it determines the magnitude and the what? Sign of the what? Power. Are we together? So with this now, I think I've explained how to convert a number from ordinary form to what? Standard what? Form. Are we together? Now, another thing I want to talk about is how do we now convert a number from standard form to what? Ordinary form. That's another area now we want to look at. How do you convert a number from? I have defined standard form. I've told you why we use standard form. That is the importance of what? Standard form. The application of what? Standard form, right? I have given you examples of numbers in standard form. I've told you how to convert a number from ordinary form to what? Standard form. I'm about to talk about how to convert ordinary form back to what? Standard form. I have discussed about 4 subtopics now in this topic. So we want to talk about how to convert a number from what? Standard form back to what? Ordinary form. So that's what we want to do now. If you permit me to clean this board, I'll clean it. Now, so we are going to look at how to convert number from where? Standard form to what? Ordinary form. Do we use the same number?
Yes.
Or do a different number? Any question? Nature?
Yes.
Ask. Yeah, which one?
The second one.
This one.
Assume that 6.4370.
The
As in the numbers are not zeros.
okay. The number. Call it again. 3 what? 6. 6.4. 27 what? 8. To standard form. To standard form.
Yes.
Just simply do 3 square what? 0. If this is the second one, open up. You can simply you cannot accumulate this to maybe 6.4. That's it for what? This is standard form. I'm coming. 6 point what? You say okay, it's not bad. I'll mark it. It's okay. It's okay. I'll mark it. I'll mark it. It's okay. It's not bad. Which one? This one is what?
Is it 8.7 times 10 raised to 4?
Okay, if you want to put it to standard form, see it here now. It's 2.9. If you want to put basically standard form is like this. But it's not stable. So let me get a question. Do you ask me to put it in standard form?
The question is 29.87.
Now I'm saying this is 29.87.
Okay, if you want to start something, start from 2.
The first thing to do first is to put 0 first. Put that times state point. It's already in standard form. But is it stable?
It's not.
So this should do what? Move to this place. It becomes what? So you have 2.987 times 6 power what? 1. Even if you do this in 3.0, I'll mark it for you. Times 6 power what? It's okay. Are we together? Am I communicating? Or maybe not to round too much. You can leave that 2.99. I'll mark it. It's okay. You may be given a number. You may be given 3. I may be asked to put it in standard form. What is the answer? Don't correct it. Not 3.0 times stage power 1. What is that? 30 go now. It's 3.0 times 3 power 0. That's another form. And that's the answer. That's the answer. It's the stable form. That's the answer. These are questions to ensure that to find out whether you actually understood what standard form is. You may give me a number, just 1 digit, and ask to put it in standard form. Naturally, you be looking for 0.0. You say 0.00. What is all this? So 9. If you want to put 9 in standard form, you simply what? 9.0 times 10 power what? 0. That's why I said that before you can understand standard form, you must first of all understand lots of what? Indices. Simple. And I don't know if you asked a question. You asked someone was talking here when nature was asked. Okay, you okay now? All right. So now let's move. Okay.
So you said.
Sorry.
10 raised to power 0. And you said the laws of indices, 10 raised to power 0 is 1. Does that mean
1.
that this thing is 1?
Okay, which one is 1?
Like
This one. Everything here.
like that, what are you doing? Like, for example, wait, like this one is
Okay.
you said the answer of this one is 10 raised to power 0. And any 10 raised to power 0 like your na indices
It's 1.
Or na mean na like all ona iya de kita 1 ka gakwe.
Times 1 now. The same number.
Matter dey 6.4278 times 10 power 1. Is it the same thing?
No. This is 10. You multiply. This is 10 power 1. Enter the raised power law of indices again. Law of indices again. Enter raised power 1 is what? And number raised power 1 is what? That number. So if you write 10 power 1 is 10, you are writing here. So that means you're multiplying 10 times this thing up to go. It's not setting again. But this number times 10 power 0 is the same number. True of us. Because this 10 power 0 is what? 1. We are using 10 because the base in the standard form should be what? 10. That's why we are putting it to 10. So if you raise 10 to power of 0 is what? 1. 1 multiplied that number is the same number. But if you make it to 1 here, you multiply, you won't get the same number. Now, okay.
This computer email. So does it mean that like that 27?
Which one?
9.
Okay. Shh, please, no, please. Hello, please. That's wrong, please. Focus, please.
So does it mean that you move from that point that
Here.
the next one, that point will go to the
Yes. That's why it's a movement now. Do you move and stay where you are? Even though this is movement anyway, but when I move, I mean moving from one point to what? Another. You move. It has moved. It will shift another pace. Or I call it shift. Anyone is okay. Is it clear? Yes. Are you okay now? Now let's go to let's convert. I asked you because I said, do we convert the same number back to ordinary form?
Yes.
Okay. Here in the now let me see. We got 4, 8 what? Here.
4,879.
Here, what did we get here? Let's put it to the one decimal place, okay? 4. Okay, let's maintain it there so we can see whether we got the number or not. Times 10 power what? Here is what? What? Here, uncle?
2.987 times 10 to the power.
What? 1. Now, let's move this now. Let's convert this number. Let's convert 4 point what?
879
Times 10 power what?
3.
To what? Ordinary form. Now, listen. Look at this number now. Before you can convert a number from standard form to ordinary form, there are 2 things you consider. Check the number. What you have in the power. The magnitude of the power will determine the number of decimal movements you will have. Okay? So look at this now. The magnitude of power here is what? 3. So the 3 there, 3 here now, that means we have 3 decimal movement here, right? But we don't know the direction we are going. So the sign of what you have there will tell you the direction you do what? Follow. Are we together? So with that at the back of our mind, this is the what? This is the what? Decimal what? Point. Are we together? This is the what? Decimal what? Point. Now, what is the sign here? Positive, right? The sign here is positive. So, for us to be able to change this number to ordinary form, the target is to make this space to be what? 0. Are you aware? Yes. The target is to do what? Make this power to be what? 0. This power to be what? 0. That's the target. Yes. In moving number from a standard form to ordinary form, the target is to make the power to be what? 0. Once the power becomes 0 and renders everything there 1, you have succeeded in moving that number to the what? From standard to what? Ordinary form. Now, look at here now. What do we do? For this 3 to disappear? We know we move. So the movement should be reducing this 3. True of us? Yes. the movement you will take should be reducing this 3 what? 3. So any movement you can make that will reduce this 3, you do it. Now, this 3 now is positive, right? If we move here, do you think it will reduce the 3?
No.
Huh?
No.
If you move here, do you think it will? Check well before you answer. Will it reduce it? Your email one movement, will it reduce by 1?
Yes.
Email also will it reduce by another 1?
Yes.
Are you sure?
Yes.
That movement, is it to the right or to the left?
Right.
This is right, right?
Yes.
Right?
Yes.
1 is right.
Yes.
Good. So if you move, okay, let's just run that. Before I give you a rule now, let's run this down. Let's see. All right, let's move. If you move 1 here, what do we have here? Times what? Move again, it become what? 0.9. Move again. Here is what? True of us times what? Which is what? So that means, okay, I don't say anything yet. Let's check the what? Negative 1. Before I can give you a rule on this. Let's look at this negative. This negative, right? So this is what? 7 what?
7.8
Times what?
10 raised to the power -2.
Minus what? 3. Remember our target. Our target is to do what? Reduce or what?
Power to 0.
Is it? Do we reduce the power or increase power?
Increase the power.
We do what?
Increase the power to 0.
We increase its power to what? 0. Minus 3 is less than 0 and true of us. So the target is to increase the power to what? 0. So you can either hit what? 1. Now what can we now? That means any decimal movement we make here will increase this power to what? 0. That by 1, right? Now, do we think we should go like this? Or like this? Like this, right? Right. Let's move the first one. The point is here, right?
Yes.
It will become what?
0.78 times 10 raised to the power -2.
Minus what?
2.
Good. Let's move again. You form what?
0.078 times 10 raised to the power -1.
Let's move again.
0.0078 times 10 raised to the power 0.
This becomes what?
0.0078
Times what?
1.
Which is what?
0.0078.
Now, as a rule, can we make any deduction from this now? Watch out. Let's test to them, and so I know whether it's actually what truth. Come in. Have you noticed something here? That as you're moving from standard form to ordinary form, as you move decimal points, if you move the decimal points in the right direction, the power is reduced. True of us? So as you're moving, converting from standard form to ordinary form, if you move decimal movement along to the right will reduce the power by that number of what? Decimal what? Movement. So that means to reduce this power, to reduce this power to 0, you move to the what? Right. So if you move to the right, the power will do what? Reduce. Now, but if you move to the where? Left. The power will do what? Increase. As you move to the left, the power will do what? Increase. If we are converting from where? Standard form to what? Ordinary form. Let's recall what happened in the converting ordinary form to what? Standard form. What actually happened there? If you have a number like this, 0.00 watts, 78. The target is to move this point to this point, right? Yes. For it to be in standard form, right? So as you move to the right, the power does what? The power does what? Remember here is stated power what? 0. As you move to the right, the power does what? Decrease, right? Yes. Decrease, right? Yes. But here, as you move to the right, what happened? Listen critically. I want to compare something. As we are moving from the ordinary form to standard form, as you move decimal point to the right, what happened to the power?
It decreases.
It does what? It decreases, right? Yes. Right?
Yes, sir.
Now, here now, as decimal point moves to the right, what happens? Decreases. As decimal points moves to the right, the power does what? Decrease. Here again, as decimal point moves to the what? Right, the power does what? Decreases again. Let's check here. Here is normally 487 times 10 to the power what? 0. At decimal point, move to the left. The power does what? Increases. True of us? True of us? Now, let's check here. As decimal points moves to the where? Left. Does it increase or decrease? Increases. The same thing with here. True of us? So, as a golden rule, as decimal points, decimal movement to the left increases the what? Power. While decimal movement to the right decreases the what? Power. So decimal movement is actually opposite to the what? Increment, change in the what? Power. I'm teaching you how to make deductions in study. That's where Jabo, some people are asked questions before you know HMK has idea, because they have done the what? Deductions and keep it. As in just one straight line, decimal movement is opposite to the changes in what? In the what? Power. So as the decimal movement moves to the left, if the decimal movement is to the left, the power will do what? Increase. If the decimal movement is to the right, the power will do what? Decrease. Irrespective of whether it is less than 1 or more than what? 1. Or whether you are moving from standard form to ordinary form. Or you are moving from ordinary form to decimal form. To standard form. The golden rule is that as the decimal movement to the left gives what? An increase in the what? Power. While decimal movement to the what? Right decreases the what? Power. Simple. That's what I'm trying to let you see with your eyes here. before I state it for you. So as you are writing, you know what you are writing. You don't go and cram it and forget it. Maybe in exam you blew continue by where down like they call 20 questions because you what are you cram and what you cram you can do what misplace them. True of us.
Decimal movement is opposite to what? Decimal movement is opposite to what?
I said the decimal movement is opposite to change in the words power, the magnitude of power. So what it means is that decimal movement to the left will do what? Increase the what? Power. While decimal movement to the right will do what? Decrease the what? Power. So once you know what if you know your number line well, you know minus 3 power minus 3 and 3 power 2. They can true of us. So with this, I think we have succeeded in discussing how to move a number from ordinary form to what? Standard form, and from standard form back to what? Ordinary form. That's what we have succeeded in doing today. Now, so the next area we'll go into is operations in what? Standard. I think standard form is the only notation that's remaining. Is there any notation we have not touched? Standard form. That's the only notation that concerns us in this course, okay? That's all. You've done your log with it now, so I don't want to waste my time there. You just did it like yesterday. So that would have an issue. Even came from one. You don't say it. At least you passed it. So if you question my algorithm, I know you pass mass one year, you don't know that means something is wrong. You come here and confess what you did. I'm not blaming you. I can't make you do one here now. You have to confirm one. So there's nobody here that says that you don't know how to solve logarithm. Now, so I think after the standard form, then we now enter our next topic. So, but I want to ask if there's anything confusing here. Then operations is what's time? Okay, 9:40. I think our time has elapsed.
Yes.
Or do I continue? Chiemeka want me to continue. Okay? I should continue, right? That's it.
And this one, the sentence, the unit
Is there any question like that?
No, as you know, we saw this one before you now gave us something like that.
Okay.
So I'm just asking, in case in an exam or test, this percentage appears in this form.
Okay, concentration. No worry. Hello. Somebody asked a very important question. The person said, what if in calculations you start seeing some question, you see percentage. See, we just what the percentage we discuss here is percentage in general. When we do concentration, we go back to percentage again. That's when we'll make it live. I'll bring the percentage. You understand what concentration is with respect to what percentage? We discuss that one in details when we discuss what concentration. I'll go back to percentage. If you watch, I just explained it and stopped because I know that I'll still go back there with respect to concentration. We now appreciate it well, even though I'll still look for some questions, some radar scenario that has to do with normal percentage we are calculating with respect to maybe I'll get some practical oriented questions before we conclude this topic. Maybe one or two. We'll still do it in this class. But for now, let's leave it at that, okay? So in our next class, We'll continue, we'll do the operations. We'll look at addition, subtraction, division, and multiplication of what? Exponential what? Notation. So that will be the end. Enumeration and notation. We'll now enter. Then we'll start our quiz on this topic. While we enter the third topic, which is rounding, right? Approximation and the estimation. As that one is going on, we will write now our quiz on this one. So the moment the day we finish the two topic, the next lecture, we start our quiz on it. While we introduce the next topic.